Hello everyone. In this video, I'm going to tell you how to design that triple five timer working under monostable operation. So this is a standard triple five diagram, IC triple five diagram. So we used to connect, pick one triple five timer and connect 4 to 8 pin. 8 pin connected to VCC 5 volt, and one connected to ground, and one five connected via through 0.01 microfarad. This is a standard connection, and third pin output you connect to one resistor. So we'll want to work that triple five time in monostable operation. You need to connect one resistor and then capacitor, right? In stable we connected two resistor and one capacitor, but monostable we connected one resistor and one capacitor. And second pin we are going to apply the trigger signal. So as you know that operation of the monostable, when the trigger pulse is applied, then we'll get the stable state, right? So usually I connected this resistor and capacitor, and this point as usual connected to eighth pin. This point connected to sixth pin, and this is seventh pin shorted here. So that's all about the connection. So but second pin we are going to connect the trigger signal. For that we select the component V pulse. So here you have to search V pulse, pick that V pulse, and we are going to apply that negative V pulse. So you have to rotate this one, right? I'm going to apply a negative V pulse. So for negative terminal connected to second pin, positive terminal connected to ground. So one more ground you have to select. So pick that wire, you have to connect this to. So that's all about the connection, but very important is setting that V pulse attributes. So how to set the V pulse attributes? Just select DC 2 volt, and go to V1, save attribute, go to V1. V1 is nothing but top one. So select minus 2 volt, and plus V2 is the bottom. V1 select 1 volt. Here I'm going to apply V2. Yes, V2 select plus 1 volt, save attribute, and uh, time delay, rise time, and then fall time. So time delay you have to set zero point 0.5. Time delay, rise time, and fall time. So rise time I'll set 1 milliseconds, and fall time 0.5 milliseconds. So time delay also 0.5 milliseconds. Pulse with zero point 0.5 milliseconds. So that's all about. So save attribute, close. So first you have to check it how the pulse will be, and go to analysis as usual for running setup. Set up the file transient change into 20 milliseconds now, and then take one probe and connect it here. First check that pulse how it will be. Yes, save mono stable triple five, and take the pulse here, and first run this one. We'll check it the pulse. So this is about pulse. So plus one and minus one, negative pulse. So the negative pulse is going to give as an input in the trigger signal, and due to this negative pulse, what will be the output in the third pin? You have to check it here now. Again, you have to go to simulate. So the time period is not matching. For the trigger pulse, we'll get one stable state on. So here the time period is not matching. So you have to set the time period, and so just do it some correction in that V pulse. Set that V1 minus 2 volt, V2 plus 2 volt, and time delay 0.25 milliseconds, rise time 1 millisecond, fall time 1 millisecond, and pulse with zero point 0.5 milliseconds, PER 5 milliseconds. So this attributes is very very important. So both rise time and fall timers are equal, and time delay is minimum, and pulse width is zero point 0.5 milliseconds. So this is very very important. So select OK. Then we do it simulate. Connect the probe in the third pin and do it simulate. So we'll get the waveform like this. So whenever the trigger is applied, negative pulse is applied, we'll get an stable state. Right? Whenever the trigger is applied, we'll get output is one. Right? Otherwise, the output is zero. So this is what monostable operations. Whenever you press the switch, we'll get the output is one. So this is what monostable operation. And I will just say connect to see the output across the capacitor. What happened? So select this probe and connect it here, and select that, check that output across the capacitor, do it simulate again. So we'll get that output like this. Actually this is charging and discharging, but due to some factors we'll get the output. So we will do the time settings, we'll get the proper output. Thank you.